All right, so this is where we left off with yesterday. So it's important to know which valve is located in which part of the heart, and we'll go through that here in just a moment. And the reason I think that that's important is it allows you to think about that and visualize that as I go through the this diagram that we have here. Juniors that were gone doing smarter balance testing yesterday. We talked about this yesterday in class, so we will talk about that here in just a moment. Okay, so the anatomy of the heart. Okay, so when we talk about the size, think about the atriums are smaller than the ventricles. So why might that be? Okay, so just think about that for just a moment. Okay, and then also, if the atria are smaller than the ventricles, which they are, why does that explain the ventricles have to be much larger than the atria? So once you've taken a couple moments to think about that, and I think a simple way of looking at that is just called the workload. Okay, and when we say that is because of the short distance, and when we're pumping from the atria to the ventricles, it's basically just draining from the top part of the heart to the bottom, okay? So keep in mind that you don't have the left side of the heart contracting while the right side relaxes. That's just not how the heart works. You have the atria that are going to pump while the ventricles are relaxing. And then the exact opposite would happen. Is the ventricles are contracting while the atria are relaxing, okay? So when we think about that, those are specific terms called systole and distole, and we'll get to that here in just a moment as well, because that is referring to what we call the cardiac cycle. Okay, so path of blood through the heart. And one of the things that happens is the blood will not flow backwards, at least it's not supposed to. And that's why those valves are located within each chamber of the heart to prevent that. And one way to think about that is for anyone who's ever dealt with flooding in a basement, and maybe you might just accept that, well, we're talking about this and saying, well, there's a one-way valve in our heart. That's just what the teacher told us or the professor, so I guess we just must have to accept that. Well, yeah, possibly, but a better explanation for that would be how I have a greater appreciation for plumbers, let's put it that way, okay? So here is your sub pump hole, and then what you have in here is your sub pump, okay? And it sits just above, we could say, just above the bottom of your hole there. And then typically you have PVC tubing coming out of there. And then depending how the lining of your basement is, like in our case, having to cut this distinct length. And don't be drawing this is just to make a comparison and say why there's valves located in the heart. And this will make sense in just a moment. And then if you have to put this PVC tubing up into the floor joists, that's why I say I certainly have a certain appreciation for plumbers now, because you're going up and sideways and all other directions trying to make your way through these joists to get to the outside. And then there might be a 90-degree angle. And then it's exiting out the side of the house. Now, this could very well be, I want to say, maybe about 6 feet up above our sub pump hole. Then it goes to a right angle, and then another right angle, and then out the side of the house. But what happens is right here, I don't quite have this right. Darn it. It's close. That's what I meant to draw. Okay. Now, there, that's better. Because what you might want to install is what's called a check valve here. Okay? Just like the heart has valves inside of it, you might want to put a check valve in here. Because what happens is, this is the float that would turn this pump on and off, is that as this continues to go up, that means your water level is going up, okay? So that pushes the float up, it engages this, and water starts to flow out of here, okay? Then your float goes down and it shuts the unit off. But the reason you have a check valve in here is that as water passes this valve here, you don't have to put one of these in. But if you don't, you pump water through here without that check valve, it eventually reaches the top whenever this float shuts off, then any water that's in this tube here is just going to flow back down into your sub pump hole, okay? And then this turns on again, and then it might pump water up to about 3/4 the length, shuts off. Then water comes back down again. Then does the same thing, and it might continually cycle that. But once you put a check valve in here, that will flip upwards, and then as it shuts off, water can only get back down to where that check valve is. And that's very similar to how the heart works. Once blood has pumped its way through one of these structures, okay, we'll just do this down here. This is what we call very similar to that of a check valve. It does not allow that water, or excuse me, well, blood is water. It does not allow that blood to flow backwards, just like this check valve does not allow water to flow back into your hole. Okay, the idea was to hopefully make a clarification or distinguish why the heart has valves inside of it, and hopefully that makes sense. Okay. So then think about the left ventricle is larger in size and composition than the right for the same reason, because of the workload, okay? Where is blood leaving from the right ventricle? Think about that. And if you said lungs, that would be correct. So if this is going to the lungs, then this must be sending it to the rest of the body, and that would be correct. So then what type of circuits are we talking about? Okay, if this is going to the lungs, this is the pulmonary circuit. If this is going to the rest of the body, whether it's going up to your cranial region or down to your legs, to your feet, that's the systemic circuit then. So again, we have a double circuit within our circulatory system. Okay, so now we're eventually going to start talking about how blood flows through the heart then. Okay. And maybe this is what you would have observed yesterday. So with this specific anatomy that we see here, okay, maybe it would make more sense to just go ahead and write this down, because as I'm standing here, we've got this is behind a bright light, and it's probably pretty tough to see. So we'll try to keep this under 15 minutes. So go ahead and take an opportunity to write this down. And then you may have to hit pause, and then that way you can fill in the rest of this content. I don't even know if that laser pointer show. Oh, it doesn't, because I'm pointing right to this right ventricle here. No, you can't see that. Okay. Okay. Okay, and as we continue to move forward then, so keep in mind the heart is a muscle itself, so even though the heart pumps these needed nutrients and oxygen throughout the body, with it being a muscle, it has to have that vital supply of nutrients and oxygen itself. So how that happens is the idea that we'll see this in just a moment. The very first branch off of the aorta is actually the coronary arteries that supplies blood to the heart. We typically think, okay, what's going to be the first branch off of the aorta? I almost said subclavian. That's not correct. The brachiocephalic artery, the left common carotid, and there's 3 of them, and you will be responsible for. I'm just trying to go from memory. You have the left common carotid, and is that the axillary and maybe the brachiocephalic artery. We'll talk about that later on in this chapter. Okay? And then if you have coronary arteries, well then you'd also, I think this should say coronary veins then as well, rather than cardiac, okay? It's because these run parallel with the coronary arteries, which will drain blood from cardiac tissue back into the right atrium. And the reason that's important is because if it's going into the right atrium, it's depleted in oxygen and nutrients, which would make sense. So that way you continually supply that vital muscle with the oxygen and nutrients that it needs. Okay. So when we think of parts of the cardiac cycle, what that means, if I'm interpreting this right with blood pressure, you're always given that number. For those of you who have donated blood, they will put this sphygmomanometer, I think is how you pronounce that, and it will take your blood pressure. Okay, that's obviously different than the stethoscope. They're just listening to your heart sounds, and then this sphygmomanometer, I'm sorry, you know what I mean. That will give you the numbers where typically you think of average somewhere around 115 to 120 over the bottom number, which is probably somewhere 75 to 80. So when you hear that blood pressure, it's saying 115 over 75. I sure wish that was my blood pressure all the time, but that is not the case. Coffee probably does not help, so it's different lifestyle choices that people choose. But then where do you draw a line? Caffeine is known to raise blood pressure, but it's also known to help fight cancer, oddly enough. So you have to make your choices on what you think is valuable to place into your body and what isn't. Okay, so the 2 parts of the cardiac cycle are called systole and dystole. And one way to look at that is when systole is happening, the atria are contracting, I believe. And then when dystole is happening, it's the ventricles then. Okay, see if that is correct. Okay, systole, yes, the atria contract while the ventricles relax. And then just the opposite happens, and the ventricles contract while the atria relax. So it's this type of mechanism where the pump, this is, I believe, that larger number. We said 115, and then when this pumps, it's that smaller number, right around, hopefully, 75. So 115 over 75 is your blood pressure, and this is what's actually happening inside your heart. Okay. I said I want to keep this under 15 minutes. We going to be able to do that? We can save that for next week, just on account of very important weekend. I meant to mention this in the first hour class, so hope you enjoy your weekend. Make the best of these high school memories. Hope it all works out well for you with the weather. And again, enjoy that time and this path you're navigating known as high school, the best times of your life, we hope. So I didn't get to this part, but we'll save that for next week. So we will catch up to you next time. And again, please enjoy your weekend, and we'll catch up to you on Monday.